So far this week, we've talked a lot about steak, but elasticity is a concept that occurs in many different foods, and soon you're going to see an excellent example of this when Bill Yassi's cooked strudel for us. So strudel has a lot in common with other bread doughs, and we're going to talk more about this later on in the course when we talk about baking in general. But for the purposes of this segment, I'm going to tell you a little bit about gluten. And gluten is the protein that gives strudel dough its very, very special characteristics. So gluten is a component of flour, and it's a protein. And the protein content is usually about 10% in flour, although it's going to depend on where you buy your flour, actually. It's going to depend on where in the world you buy your flour, but also where in the US you buy your flour, but usually around 10% or so. The rest of flour is about 70 to 80% starch or carbohydrate. So a large part of the protein in flour is going to be composed of large molecules that are called glutenins or gliadins, and these are the molecules that make up the gluten network. So the structure of the glutenin molecule is especially what contributes to the elasticity of the gluten network. And here's a picture of a glutenin molecule. As you can see, it is a long molecule, and it's a large molecule, and it has a coiled structure to it. And it's built up of amino acids, since it's a protein, and some of these amino acids are going to be charged, although most of them will not be charged. The special property of glutenin molecules is that some of the amino acids are cysteine molecules. And cysteine amino acids have a sulfur bond on them. And this sulfur can form a very, very strong bond with other sulfurs on other cysteines in other glutenins. And so what ends up happening and what's causing the gluten network to form is that these cysteine molecules bind together with other glutenin molecules, and they cause this very intricate network and very, very large network of glutenin molecules. So when we first mix flour and water and maybe oil and salt, what is happening is that all of these glutenin molecules in the network is very, very messy and all over the place. And then as we start to knead the dough, we're slowly unfolding the glutenin molecules, and we're unfolding the network, and we're aligning them, and they are going to be aligned so that there are hydrophobic interactions, van der Waals interactions of the hydrophobic kind, that are binding them together. Now, what happens as we're kneading and as we're stretching the dough is that these bonds, they're weak. They're strong enough to hold the molecules together, but as we knead the dough, they start to slide the molecules along each other, sort of like this. And this is what's giving the elastic property of the gluten network. And so as we work the dough, we get more and more of these aligned molecules, and this is then making the dough more and more elastic. And this is very similar to the crosslinks we've talked about before. It's just a different kind of crosslink. So this is what happens when we stretch the dough. So as we stretch the dough, the molecules are gliding along each other, and there's going to be some give, and this is the elasticity of the dough. So as we stretch them, some of them are going to kind of relax back. But as we stretch a lot, there's also going to be new hydrophobic interactions forming, and this is what's keeping the dough stretched out. And this is called plasticity. So when you stretch something and it doesn't completely recoil to its original shape, that's plasticity. And when it does recoil to its original shape, that's elasticity. So now that we've talked about this, let's watch Bill make strudel dough for us.